Okay, it's 5 p.m. So we will start our webinar today. This is Global Green Development Alliance, the webinar number 73, Health World Green Development. So this webinar was organized by the several organizations from the 2020 to now, about 73 years. So our co-organization has the US-China Health Summit, Global Green Development Alliance, and the Green Development Foundation, and so on. So I'm Xiaofeng Zhang. I'm the moderator for tonight. I also the president for the Global Green Development Alliance. So I'm really happy today we'll introduce our significant speakers, and our topics is very interesting for everyone. So I believe today is good afternoon or good evening in the United States, and a good morning for China, and a good day for other friends in the world. So I will start share my screen so you can see our webinar introduction. Okay, so today our topics is world energy decarbonization pathway. So we have 3 significant speakers. So the first one is Dr. Nan Zhou. She is a senior scientist of Lawrence Berkeley National Laboratory, technical program manager for the Net Zero World Action Center, co-chair of the Academic Advisory Committee of California China Climate Institute. So second speaker will be Wei-Jun Leschers, Principal Scientific Engineering Associate at Lawrence Berkeley National Library. So our third speaker will be Dr. Richard Dasher. So he is director of US Asia Technology Management Center, Stanford University. So after then, we will have 40 minutes Q&A. Moderator will be Dr. Apple Zheng. She is the Vice President, Global Green Development Alliance. So before we really start, I would, short introduction of our organization. So everybody know our subject related United Nations climate action, so to 2050 zero carbonization. So all the world is work together to try get green gas emission. And so we will separate by the several business industrials, transportation, electricities, industrial, agricultural, and so on. So I will not spend too much time for the general introduction because our expert will talk much more details. So just the one slide talk about currently what we are viewing in the world. So the US has a zero carbonization by 2050. So based on this, California set a goal is more aggressive, is 2045. And a lot of industrial private sectors, so they have climate pledge they will be tried that 5 years earlier by 2040. So this was led by Amazon and other organizations. So today, our three experts will talk about how the global, decarbonization and each country, how can we will do. For us, Global Green Development Alliance, our senior management also long time involved renewable energy development and also participant a lot of earlier stage conference, for example, like 2011. So that time is US and China, clean energy proactive cooperation strategy forum. So this slide just a little, I will like this one because they talk about United States, 50 states, renewable energy, clean energy, and standards, and so on. So we don't have time to talk details. However, you can see US is each state, doing their best, to move to this goal. So the US private sectors also did significant contributions. So like earlier, we talked about a lot of companies like Apple, this is the leading company. They said they already got 100% renewable energy. So we will see the, their effort, how can help our global decarbonization. In the California, as I know, in the 2020 already reached 33% renewable energy. So this is some screenshot by that time, show the California, the big progress. Okay, so we will get time to our expert to talk more. So I just has a few lines talk about our organization, Global Green Development Alliance is a 501c3 nonprofit organization. Our head office is in the San Francisco Bay Area, California. So most we are focused on global clean energy, fighting climate change, and the public health. So we have a group, professional to try reach this goal. Our operation most for the charitable and educational. So what we do, so most we can say the three sentences. So the first is the dialogue, webinars, conference, and so on. So second is leadership development. So we create the young professional group from age, they get in the college to their study, PhD, and after that. So we try, training and raise the new star. So third one is we also doing some, project related things for the renewable energy, smart city, transportation, and so on. So we just show few flyers for our webinars. So from 2020 to now, we organize a lot of webinars. So in the left side, you'll see first one is 2020 when we started with fight for coronavirus and also talk about clean energy. So also talk about economic recovery, use the AI for energy. Right now, AI is more smart. Maybe our next webinar we will talk about that. Also, we talk about energy efficiency and so on, and the policies. So here is other group, we talk about California, the energy crisis in 2020, also 2021, the Texas energy crisis, and talk about Paris conference, and we discuss the US-China cooperation and so on. So we also organized the conference. This is the one in 2021, Global Green Development Summit, Energy Transaction and Innovation for the Carbon Neutralization. That was in the Chengdu, China in September 2021. So we have a lot of experts in China. They are come to Chengdu, and the international expert most is online. You can see this is the some of our speakers. So they have maybe 4 or 5 academics from China, also the US expert like the Professor Daniel Kahneman in UC Berkeley, Professor Jim Sweeney in the Stanford, and so on. So my last slide is talk about our young professional group, like today's moderator, Dr. Apple Zheng. She is our young professional co-chair, also vice president of the Global Green Development Alliance. So we organize the 2 forums each year, So we will continue to promote the young people, and they will be our future. Okay, so thank you. So if I use one line, talk about our organization is together for reshape the world with the clean energy, better healthcare, and a healthy environment. So thank you. So our webinar will be start now. Okay, so we will exciting to announce our webinar. So our first speaker is Dr. Nan Zhou. She is well known in the industry for the UC, not UC Berkeley, okay, Berkeley Lawrence Research Lab. And so she did a lot of significant contributions. So she participated IPCC and other important report. So she also is the group leader of the China Energy Group and the head for International Energy Analyst Department. Okay, so we already wrote everything, in our announcement and also in the website. So right now we get the time to the Dr. Nan Zhou. So welcome.
Thank you, Director Zhang. Thank you very much for the kind introduction. So today, I and my colleague Virginie will be presenting to you some of our recent research findings, particularly related to the global energy transition, decarbonization, the pathways. And specifically, I will quickly talk about the IPCC 6 assessment report findings, for which I'm one of the lead authors, and how that impacts and our future and energy outlook and our lifestyle, and then dive into a number of the key emerging economies, including China, Indonesia, and Chile. So I will start with this IPCC implication. From the recently released and 6 assessment report, it was concluded that average annual greenhouse gas emissions and right now is at the highest level in human history. And next, please. And as you can see from this chart, the global GG emissions has been growing, and we have not seen a plateauing or decline that is needed and to turn the trajectory and to achieve 1.5 degrees C target. And from the different greenhouse gas emissions, you can see most of the growth and still come from CO2 emissions, mostly coming from burning of fossil fuels. There are other greenhouse gases such as methane and F gases, and also have been growing. But the majority of the growth is still due to the CO2 emission. Next, please. So unless there are really immediate and deep emission reduction across all sectors, we concluded the 1.5 degrees C is really beyond reach. And so, which is a very and a little bit pessimistic and assumption. But at the same time, I also want to call out that some hope with the increased evidence of climate actions in all the countries. And some of the countries already achieved a steady decrease in the emissions that's consistent with 2 degrees C scenario. And a number of cities and regions announced their zero emission targets. So these offered some hopeful and future outlook. Next, please. In some cases, and many of us have seen, the cost for key renewable energies have fallen below even those of fossil fuels. And then you can see the cost for PV, onshore wind, and even battery in the last 20 years have all declined drastically. And particularly for photovoltaics and or wind, already lower than gas and sometimes even than coal, in many parts of the world. And you can see the adoption of these renewable energies, and also has been growing and at a very high growth rate for all of the technologies. Next. So next, please. So the trends overall for the future by 2050, it shows that, and if we want to limit the warming to 1.5 degrees C, the global GHG emission needs to peak before 2025, which is only in 2 years from now, and reduced by 43% by 2030. Methane needs to be reduced by 34% by 2030. And if we're aiming to limit the warming to around 2 degrees C, and then also the emissions need to peak before 2025, reduced by 27% by 2030. As you can see with today's and where we are, and also with the currently planned policies and targets, which is shown in the red scenario range, you can see we do have a big gap in achieving both 2 degrees C scenario and the 1.5. Next, please. So the temperature will stabilize when we reach net zero carbon dioxide emissions. There are options, strategies, and we can deploy and now to help stabilize the global climate. Next, please. So these are in all the keys in the society in the different sectors. And for energy sector, land use, industry, urban, building, transport. Fortunately, we have sufficient technologies, practices, designs to help us achieve, for example, net zero energy buildings and net zero transportation system, mostly for passenger cars. And although aviation and shipping is still a challenge, we also have a significant amount of technology to improve industrial energy efficiency and then improve the material efficiency. Next, please. So in all the chapters, and it concluded, and we have a range of these strategies fall under these different categories, including the energy and the material efficiency, electrification, and then in the end, enhancing the carbon uptake and the storage in the urban environment. Next, please. Keep going. Thank you. So to conclude with this IPCC implication, and To achieve this technology deployment, we need to accelerate the climate actions using market and the regulatory and policy and instruments. So for investment, right now, we are 3 to 6 times lower than the levels needed by 2030 to limit the warming to below 1.5 or 2 degrees Celsius. Globally, we have sufficient capital and to help close the investment gaps. So the question is, how can we steer these global capital toward these climate and mitigation strategies and also a clean energy transition? There are also plenty of policies, regulatory instruments we could utilize. And similarly, the question is, how can we accelerate and the adoption of those policies? And at the same time, we need to accelerate technology innovation and to really help and shorten the time and the speed needed and to achieve the technology to market. Okay, next, please. And then with that, I will shift on to a deeper dive on the China future outlook. And at the Berkeley Lab, we just finished. And so the report and has been completed, and which covers 3 chapters. The chapter 1 and discusses current energy and emission trends. And chapter 2 talks about key energy targets, policy programs, and chapter 3 is about the future energy and emission outlook. Next, please. And we evaluated 2 scenarios. One is a continuous improvement scenario in which we look at what China could achieve if it fully adopts and the feasible share of today's commercially available cost-effective technologies by 2050. And more or less continuing on existing policies and targets and the planned goals. For a deep mitigation scenario, we look at all the technology we know today, technology practices, design, behavior change, everything we know today, including those are still in pilot or demonstration phases. And then to see if with this adoption of the technology, could the carbon neutrality and target even be feasible by 2050 without adopting CCUS at a large scale? And so we include multiple strategies for efficiency improvement, demand reduction, fuel switching, and technology upgrades, including alternative fuels, and then including the broader structure change, and that can impact energy activities. Next, please. So what is driving future's energy and emission? So besides the population growth and the urbanization, and there are also quite a number of behaviors, lifestyle, and changes that will result in more use of energy. For example, more construction and to host more urban residences, and also more use of appliances and more comfort level, and to help us to stay cool in the summer and warm in the winter. And also related to these, and there's more need for all these industrial outputs such as steel, cement, and paper, chemicals, and it's all going to be needed to maintain a future lifestyle change and also economic growth. Next, please. And the result and for the continuous improvement scenario shows by adopting today's commercially available cost-effective technologies, CO2 emissions can be reduced by 55% in 2050 compared with 2020 level, which is a very significant reduction. Industry and the transportation sector will remain challenging to decarbonize. If you look at the chart on the right-hand side, and buildings could achieve near zero emissions in the near term. Overall, you can see the future trajectory is going to look very different from the past 40 years, which is showing on the left. And this is a very different trajectory we will need to be on. Next, please. And if we look at the deep mitigation scenario, then the chart on the right-hand side will look completely reversal from the historical 40 years, and which is really poses a significant question or challenge to our human society, because we're so used to have these economic growth, and subsequently with the growth in the energy consumption emission reduction. Is it even doable? And what are the measures and policies we have and to help achieve that goal? If you look at the by sector, and we can see the building sector can really achieve net zero, and the transportation sector emission could also be significantly reduced, although not completely gone. And if we look at the industry, it will be reduced and to half of what is today, but it's still and far from being zero. And so this has significant implications, and which more lead to the question whether we really need to work hard in deployment of existing technologies and accelerating R&D, but also leaves the question in how much can we push for carbon removal technology. Next, please. So if we dive into different sectors and to look at the key milestones needed to achieve the goal, so you see these are key metrics for transportation sector emission. And you can see, for example, the private car electrification, and with all the electric cars getting adopted widely in all the states, in countries, China is actually leading in a lot of these and the electric vehicle development and deployment. Still, at the country level, you see today we are barely at 5% of the total penetration in the entire private car fleet. And we need to achieve 95% by 2050 to achieve the deep mitigation scenario. And by 2030, that figure needs to be 30%. And so that's still 6 times more than what is like today. And similarly, we look at the heavy duty trucking electrification today, 0%. And that needs to be 75% for all the stock, not even new sales, by 2050. And so this particular sector is going to have a significant challenge to achieve the goal. And aviation today, using the share for biojet, maybe close to 0%, and that needs to be 50% by 2050. In building sector, net zero energy buildings already exist. We know how to do it. Technology exists, design exists, and it's cost effective. However, it's really just almost 0% today, and that needs to be at 60% by 2050. And for 24% by 2030, which is 7 years away from us. And the electrification of heating right now is supplied in northern China, supplied by district heating, and which mostly is still coming from fossil fuels. So that rate needs to achieve 45%, and today it's barely at 2%. So industry, and even harder for the coal used in cement industry, for example, today it's almost 90%. That needs to be reduced to 25%. So what do we use to displace those coal? And some low temperature coal and heat could be displaced by some electrification, renewable energy. But there will be a high temperature needs for industrial processes, like for cement, steel, and that will require and really emerging technologies or even CCUS combined. And there is also increased share of electric arc furnace. Today only accounts for 11%, and that needs to reach 50%. Hydrogen DRI, people talk a lot about it today, almost 0%, and that will reach 15% to achieve the deep mitigation goal. Okay, next, please. So we compared this result with other studies, and that's been published recently. And then you can see our result is in that blue line and the black line for the two scenarios. And then you can see actually we push as hard as we can to reduce the demand. So we're the lowest in energy consumption for final energy use compared with all the other scenarios. Next, please. And so really, what do we do with that 2 gigatons of CO2 that's still left after we exhausted all the deployment technologies we know today, including those pilot stage and emerging technologies? And so we think before we tap into carbon removal, CCUS, we really need to accelerate and increase adoption of existing technology even more. I showed you earlier, and even to achieve that deep mitigation scenario, we have a significant gap. But to get to net zero, that target and milestone needs to be further accelerated. Can we even do it? And it requires behavior change, lifestyle change that we have not talked a lot or addressed and sufficiently. And also requires innovative technology and mostly in terms of commercialization and of these technology, using unprecedented and mechanism. Next, please. And so there are some solutions for all these sectors, and we could still do, I listed them under these 3 categories for different sectors. And you can see there are still things we can do to increase use of alternative cement, renewable hydrogen, and low carbon, high temperature heat supply, material efficiency improvement through better quality and longer lifetime of the products, lightweight materials. And there's also circular economy concept. We can do recycling, reuse of many of those and waste materials from the different sectors. And there are also behavior change we could do, and innovative technologies for manufacturing, integrated design, and the CCUS. These are technologies or measures for industry. Next, please. And this slide shows similarly and the measures we can still do and to accelerate these technology adoption for other sectors. So for example, there could be fuel switching for agriculture, energy and consumption and end users, and also innovative technologies or measures such as restorative agriculture, composting, and many of and the concepts some of us are familiar with. Building sector, deep building retrofits, passive houses, and also personal space conditioning. And instead of using large and centralized conditioning, and in many cases there will be waste. And to reduce that, we could use these small personal space conditioning technologies. Transportation sector also, we could do more on heavy duty truck electrification, and also reduce the demand through more public transit, mode shifting, even autonomous vehicles. And there are also similarly measures for cross-cutting and sectors, and including sustainable consumption, lifestyle changes, food waste reduction, and many of these are listed here. And in the end, we need to research into direct air capture. Next, please. So to conclude, what policies we can use or prioritize for near term and the long term for these different sectors. So this slide shows and the industry key takeaways. So basically for industry, there's no silver bullet, and we need to really just implement everything, which include even efficiency improvement, these low-hanging fruits, material efficiency improvement, and at the same time, and to accelerate these tech development, research of breakthrough technologies, and also accelerate the deployment of those technologies, such as renewable hydrogen and the CCUS. Next, please. For buildings, it's more about deployment because we kind of know how to do net zero energy buildings. And also most of the technologies needed to achieve net zero building already exist. And most of them are cost effective. And so near term, we need to scale up the net zero energy building in all the sectors for China by maybe setting up targets, electrifying heating and water heating and cooking, and use green and low carbon building materials, integrating distributed renewable. Long term, and we could do more research in artificial intelligence application. I know this is a buzzword, particularly with the chat GPT, become very convenient, and that impact every sector and of our economy. And we want to really research in how we can have AI and to assist in these deployment of many of the technologies, such as improving controls, sensors, and diagnostics, and to be able to change our lifestyle and behavior, and with AI and application. And also R&D cost reduction, and to reduce the embodied emissions in building materials. Next, please. And so at the same time, we need to continue on a lot of these energy efficiency improvement and operational efficiency improvement, demand reduction, and then in transportation sector. And continue support and road transportation through also research development for hydrogen fuel cells, besides the battery technologies, and also coordinate an electric hydrogen charging infrastructure development for both public and private investment. Long term, for the transportation sector, and we need to accelerate and research more and on renewable hydrogen application, and also need to invest in R&D for alternative fuels for aviation and shipping, for which today we don't really have a good strategy for. Okay, next, please. So this is the last slide for my part of talk related to IPCC and China. So the findings from the China Energy Look basically and can be summarized as follows. 81% of the CO2 emission reduction by 2050, and from today's level will be needed. And from existing technology measures, power sector needs to achieve zero emission by 2045. Buildings and has pathway to get to zero emissions, while road transport can be largely decarbonized. And 2060 carbon neutrality goal is likely to be very challenging and to achieve, mostly due to industry sector. And China has a potential to peak CO2 emissions earlier, but it's already passed, so we see that as a challenge remains. And so we have identified gaps and milestones to help China achieve the ambitious goal, and further reduction to close the gap and will be needed. Potential area for collaboration, cooperation between US and China, and could it be and around this carbon neutrality goal achievement, and also work together on common approaches, focus on non-competitive areas such as buildings, behavior change, and new carbon neutral focus policies. Next, please. So that's the end of my part of talk. Then I will hand this over to my colleague Virginie to talk about the implications from a recent report on Indonesia and Chile.
Thank you, Nan. So I'm going to present a very similar study that we've done, learning from all the modeling that's been done for China, that we applied for Indonesia and Chile. So this work was funded by the Net Zero World Initiative, which is an initiative that was launched during COP26 by the US Secretary for Department of Energy and Secretary Kerry. And the country participating at that time were Argentina, Chile, Indonesia, Egypt, Nigeria, and Ukraine. The goal of Net Zero World is to harness the unique capabilities of the US government and its national laboratories in partnership with the countries and philanthropies to accelerate the decarbonization of global energy systems. This analysis is called the Energy System-Wide ESW modeling, and it was the first joint product under the Net Zero World Initiative, and that clearly really demonstrated the power of the collaboration between all the US national laboratories. The goal of this modeling is to establish and apply state-of-the-art modeling framework that will enable local modelers, country energy system experts, and other stakeholders to collaborate on decarbonization and investment analysis. The report was released at COP27 and is available free of charge online on the laboratory website if you have any interest in learning more about this analysis. And LBNL was leading the analysis for Indonesia and Chile, whereas other labs were leading other countries. So I'm going to talk today about these two countries, but we do have similar analysis using different models for the 5 countries. So I will start with Indonesia. So we built on what the Ministry of Energy was already doing using the LEAP model, which is the model that Nan presented, that it's a model that we use at the lab. So MEMR in Indonesia uses it to plan to achieve their NDC goals. Their NDC goal is net zero target by 2060. So it's not 2050, it's 2060. Our pathways are slightly different in the way that they prioritize the demand side measures and also vehicle electrification to reach this target. And the main difference is that we integrate macroeconomic and physical drivers and also model at the end-use level technologies for the building sector, the industry sector, and transportation as well. So you can see on the right side, the results of the model. So you can see the business as usual, the BAU emissions almost double between 2020 and 2060. It really looks like the trajectory that China was on, but Indonesia really needs to cut down its emission early, and so we managed to get to it in our model by fully electrifying the building sector. So you can see here the blue lines. We get to net zero pretty quickly. As Nan said, the technology is here, is cost effective, and so it's very much possible to reach net zero in the building sector. The two other sectors, industry and transport, that are a bit harder to decarbonize. And so you would need carbon capture and sequestration at the end of in 2060. Also, this trajectory assumes a massive scale up of renewables in the power sector, and so this trajectory is only possible if both demand side is reduced, but also the power sector is getting cleaned. In Chile, it's a bit different. So you can see, so we built, again, the ministries usually are using the LEAP model. So we work closely with the ministry, and we help them. We developed a national model for them. What they had was a very detailed 15 region. I don't know if you see the geography of Chile, but it's very long and narrow. And there are 15 different regions, the climates. And so what we did is help them aggregate this model to give them the national picture, and also identify new technical opportunities that we managed to validate with them. And so we are able to show additional opportunities through energy efficiency and conservation, best available technology and electrification, also new fuels. So you can see on the right side, so a more modest growth in the base case scenario, and on the right side, how our scenarios are more ambitious. We managed to get to decarbonization goals a bit earlier through these demand side measures. So we looked first at the building sector. So the first strategy in the building sector is really to reduce the load. And so we look at urban scale solution, which means mitigating the urban heat island effect. This means using cool surfaces of pavement to effectively reduce urban heat island effect and decrease the outdoor temperature. There's been some experiments that have been done. You can decrease, with the cool surface, you can decrease temperature by 0.5 degree to 1 degree Celsius. Also, green vegetation and sustainable urban planning can mitigate the urban heat island effect. Then the second strategy is the integrative passive building design. So this means, for example, like smart windows that can shade some of the solar radiation and reduce the heat transfer into the buildings, operable windows and openings that can bring in natural ventilation and reduce the building needs for mechanical cooling. So once you reduce the load, this is when energy efficiency comes in, and so through technology, so you can improve the system efficiency or the AC efficiency through the inverter technology, for example, which improves the efficiency by, here in our assumption 25%, but it could be a lot higher. Also, smart controls can manage cooling system set points and adjust cooling operation condition based on building occupancy. Then there's a lot of other efficiency improvement that you can do on all the end users. So that's what we said. The model has a lot of detail about technology, so we're really able to target every end use and build up those mitigation scenario. And the last one is the demand flexibility. So load reduction and load shifting. So when it means that the building can reduce some of its load when the loads are not needed. For example, if there's no one in the building, for example. And load shifting refers to displacing some of the building equipment operation from one time period to another. So it can enable to have equipment operate in a period where the grid is a bit cleaner. Also, it could be financially attractive if you have low electricity tariff at that time, or if you give the consumers some incentives to shift their load and allow to manage the load. So one example, interesting example of our modeling and of the solutions that we propose has been this peak load analysis that we did for Indonesia. So it's really, as you can see, the bottom-up methodology where we look at every end use separately and stack them up and look at the daily profile and how appliances are used throughout the day. And so you can see here that with increased penetration of appliances due to increased standards of living, that the peak demand, so you can see the overall tendency that the load just grows very rapidly between 2010 and 2030. But what's really happening too is that there's a peak that's being created between 5 p.m. and 10 p.m. There's really only a few hours where a lot more gigawatts are needed just for this time. The rest of the day, these are not being used. So it's very important to manage that peak, and this is what energy efficiency will allow to do. So Indonesia is planning to add 56 gigawatts of capacity by 2017. It's mostly thermal, so it's a lot of investment, 100 billion investment. So what we do is look at how much of that capacity can be avoided through energy efficiency, through technology. And the biggest demand reduction by far comes from energy efficiency for air conditioners. China has seen that in the past, the growth of air conditioners, once you reach a certain income level, everyone wants cooling. So this is what's happening in Indonesia. There's 7% per year increase in AC ownership. The peak coincidence with AC, because ACs are creating that peak, so it's 30%. 30% of that peak is just for ACs alone at that time at 8 p.m. So it's very important to regulate this end use, and there's a strong technology opportunity with the inverter technology. Unfortunately, the current policies have limited results, and they need to be revised to capture the potential afforded by energy efficiency. If you want to look at deeper decarbonization strategy, this is where we look at the full electrification of end uses, such as water heating and cooking. So by 2060, to get to net zero, we assume that LPG is replaced 100% by electricity. You also get some efficiency there, that efficient cooking can use about 25% less energy, same with efficient water heating. And so so with all these measures, it allows to peak the emissions in the building sector in 2030. And by 2060, is a difference of nearly 52 million tons per year that is achieved. One key assumption here is that the grid is decarbonizing very quickly as well. This is why cooling seems small here. It's because it's clean electricity. By 2030, there's already, I forgot what was the exact percentage of renewable, but in this scenario, it's a scenario from the IEA, there's a very rapid penetration of renewable energy. If the grid stays like it is, like it is now, that the results would look very different. Then the industry sector. So I think Nan mentioned quite in some details, so we will go quickly over it. So we look at at least five sectors in both countries, and then we have 5 different pillars. So the first one is energy efficiency, where we look at component energy efficiency, so motors, compressors, all the components, energy management systems, and then waste heat and waste pressure recovery. Then we look into electrification, how to expand the electricity use in industry, low temperature heat electrification, and also generation of renewable energy on site. Fuel switching to alternative fuels, solar thermal, biomass, and of course hydrogen. And then the last one that we are in the process of integrating is material management, so including material efficiency, material substitution, reuse and recycle, and then carbon capture and utilization and storage. So this is the example for Chile. So you can see that the increased adoption of electro technologies, when coupled with low carbon electricity, may have a significant carbon reduction potential in the industry sector, including heat pumps that can provide low to medium process heat and electric boilers to electrify the steam production. Other technologies such as the electric resistance heating, inductive heating, electric arcs, and infrared heating can provide process heating at a higher temperature for specific industrial processes. In the case of Chile, the steel industry and the food and beverage industry could be considered good candidates to apply this electrification efforts. So you can see under these scenarios that the industry electrification can increase from 32% in 2020 to 41% by 2030 and up to 62% by 2050. This is led by the copper industry and other industry segments like the food, beverage, and textile with low temperature application. And so you can see, because industry is getting electrified, the electricity consumption grows from 43 terawatt-hour in 2020 to almost triple, 220 terawatt-hour by 2050. So very interesting results. Again, this is combined with rapid decarbonization of the grid. So this is how we get close to net zero. In the transport sector, we have 4 different pillars. So the first one is energy efficiency across all the modes and technology, reaching best available technologies, but also considering the operational and vehicle efficiency improvement. Accelerated electrification across all road technologies, including the heavy-duty vehicles, and the adoption of alternative fuels such as hydrogen, biojet, and bioblends for aviation. And again, the last one is something we're working on, is the demand reduction and mode shifting. So it means changing to a mode of transportation that has a lower impact. And so you can see the result here for Indonesia, where we, if you compare the BAU to our net zero scenario, we managed to cut the demand by half. And so the demand stays almost flat, whereas the activity is going to be booming in the next decades. So this is possible. Yeah, so it's through energy efficiency improvement. So we assume a 2% improvement per year in the vehicles. For freight road, we assume a 10% reduction by 2050. And so yeah, all of these contribute to flatten the curve. There's still some challenges with the diesel. Those are a key source of remaining CO2 by 2060. So the takeaways of our analysis, so both countries very different, but there are some common challenges and solutions. So Indonesia, as you saw, the growth is very high. So in order to meet their net zero goals, they have the challenge to build rapidly a low carbon electric grid while the roads are growing. Our analysis has shown that early demand side action could help overcome this challenge by making it more achievable, by reducing the load, and more affordable. In Chile, which already had a very detailed plan, we managed to find additional solution to help accelerate the decarbonization, and those were not considered by the ministry, and they are considered now. So that was a big win. And so for both countries and for all countries, this is what Nan was talking about, is that the investments are really needed. Investments in cost-effective efficiency option, developing building codes, developing the standards to reduce the loads, facilitating the load shifting as well, in particular for EV charging. Those early investments are key to keep the overall cost of meeting the net zero goals down. So just wanted to mention our team of modelers. So yeah, we're really building on what the China group has been doing for the last, I don't know, 30 years. And we are adding more modelers. And so you can see we have a large team of modelers now in the lab working on these decarbonization pathways. And Nan and I would be very happy to answer any question you may have. Thank you.
Yeah, so really appreciate Dr. Nan Zhou and Weijia regarding the very good report regarding their works for the big team and several years hard work. So I will be very happy to introduce our last speaker, Professor Richard Dasher. He has been the director of the U.S. Asia Technology Management Center at Stanford University since 1994, is more than 20 years. He serves as executive director at the Center Integrated System at Stanford School of Engineering, and also he has a lot of important roles. So he also used to be advisor for the two startup companies, business venture capital firms, and the nonprofit in Silicon Valley. Okay, so Professor Rich also did a lot of research in the Asia, like Japan and South Korea and other countries. Okay, so today he will give the different views regarding the decarbonization. So we heard a lot of good research papers go to the, COP27 and so on, IPCC. So how about private sector? So welcome, Richard, to give the talk.
Thank you very much, Xiaofeng, and thanks to Dr. Zhou and Dr. Lechert for really interesting presentations. I want to start by kind of mentioning something that Dr. Zhou has said, and that is that there is no silver bullet. Industry really has to implement all of the kind of things that are being talked about in regard to achieving the goals by 2050, much less the 2030 goals. And I think that both Dr. Zhou and Dr. Lechert talked about some really good things that people can do that would have together the effect of reaching the degree of decarbonization that we need. But being aware of the things to do and being aware of the problem is only part of the challenge. We do need to start with having zero carbon as a common goal. Each sector is going to have to play its own part. Government, individuals, and the private sector of companies and investors are going to have to play their own part in achieving these goals while interacting with the other sectors. What the private sector does is gives incentive. So if you look at what kind of things the government does, first of all, the government is involved in international cooperation, such as setting the standards, developing these roadmaps of how many percentage we must decrease our carbon emissions by. Also, one of the big roles of government is regulation and, to some degree, setting standards into regulations and achieving other regulatory goals by means of taxes and financial incentives. So eventually, we will need to have carbon trading. And without the government really setting the rules for a good market, we're not going to have anything but chaos in the world of carbon trading. The other point that the government has to do is to raise the awareness of the public. The need for looking for zero carbon and also the ability that we have to achieve zero carbon. And Dr. Zhou had said this is going to involve accelerating our use of existing technologies. She said it's going to involve behavior change. And she said it's going to involve the adoption of innovative technologies. So the behavior change does not happen unless there is a heartfelt commitment to sustainability and to carbon reduction in daily life. It also involves the willingness to buy sustainable solutions, some of which may cost a little more money at the beginning. And the other thing that individuals should do is hold the other sectors accountable for how well they are achieving the goals that we are all setting together. Is industry really reducing its carbon footprint? Would we buy from a company, even if it's doing a terrible job in regard to carbon reduction? So when we get to the role of the private sector, there are two things. First of all, change starts at home. The companies themselves must make their use of carbon much more efficient. They must make their use of energy more efficient so as to reduce carbon. But they also provide new solutions that will be lower carbon footprint, new products and services. In other words, disruptive innovations that people will want to use. This idea of disruptive innovation is really important. Decarbonization is universal. It's an existential challenge. We talked about the role of government just now. What business does is it provides a distinctive type of incentive for change. People buy something because they want it or because they realize they need it. And the other point about business solutions that are provided by the business sector is that they must meet economic constraints for cost and value. So the solutions that business provides actually have a kind of sustainability that's better than you get with, say, a subsidy for some sort of behavior coming directly from the government, because as soon as the subsidy disappears, maybe the behavior disappears as well. But we really need disruptive change on the part of everybody in the economy, all sectors and all people. And disruptive innovation is an incredibly powerful tool in business. It happens briefly when buyers or users give up something that they've been doing in order to adopt some new technology or some new product, some new service. They do that because they prefer the new service. This is very powerful and it happens all the time. Think about what's happened in the camera industry. We still have very expensive cameras, but almost nobody buys a cheap camera anymore. We use our cell phone. So I think that that is a disruptive innovation. The camera industry was disrupted. There was great analysis of how this process of disruption can happen that comes from a model of risk developed by the late Professor Christensen of Harvard. He points out that there are different kinds of risk that startup companies will be willing to bear than that companies are willing to bear. So there's both the risk that the new technology or new business idea will fail, that you won't be able to make it happen. And there's the risk that it won't sell, the risk that the market will not accept it. When both kinds of risk are low, big companies are often the most efficient ways of bringing in change. So it's the large fleets that are switching to electric vehicles. Amazon, the post office will switch to electric vehicles eventually. This switchover will happen and it will kind of help pull the public market along with it. When you have a relatively low risk new technology involved, then the market will, the big companies can put in amazing amounts of money to make change happen at a system level that's really not possible for a startup company. So right now, many big companies are making efforts to rebuild their supply chain, which was disrupted by COVID, in some cases disrupted by international geopolitical tension. But as they rebuild it, they are trying to reduce the carbon footprint of the entire supply chain. We'll come back to that in a minute. When the industry knows a market really well, when it's an established market, they will spend a lot of money developing new technology. So the power industry now is spending quite a bit of money converting gas turbines into hydrogen power for electric power generation, or even in industrials outside the electric industry. But it's where both areas are high that you really need a startup to take a high market risk and a high execution risk. And this is often the source of disruptive technology. Right now, just a couple of the items here would be green hydrogen production, by which I don't just mean using fuel cells. I mean, how do you get the hydrogen to use in the fuel cell? How do you produce hydrogen without creating carbon dioxide as a byproduct? New emission scrubbing technologies still are kind of in the startup sector. So I want to look at all of these areas and see what's happening in them. In the low risk area, China is already close to mainstream with electric vehicles and plug-in electric hybrids. So almost 25% of all the cars sold in China in 2022 were either EVs or PHEVs. Europe is behind, America is even further behind, and the rest of the world is even further behind than that. But China is showing us that we can do this. In China, there are over 300 EV producers, including the world's largest, which is BYD. The price range goes from about $4,500 all the way up to very expensive. Tesla is doing well in China. And it is true that government is playing a part. They're providing incentives. They're waiving part of the purchase tax on new energy vehicles. They are making the new energy vehicles not be subject to the city restrictions on what day you can drive your car. And some places in China are even giving electric vehicles 2 hours of free parking in public lots. But basically, it's the 300 makers of EVs that you really have to thank for this. But it's a highly volatile market in China. The COVID shutdown was a real difficult thing. I would say that the next step you're going to see from the China EV makers is probably export to Southeast Asia. Charging stations are another low-risk area where the big players are by far predominating more than startup companies. So if you look at it, where do you see the private chargers in the world? Over 1/3 of them are in China. A few of them are in Japan. Quite a few, about 1/4 of the world's are in Germany. In the United States, and then 5% in Germany. But if you look at public fast charge stations, China dominates with 82%. So China has already moved ahead with technology that is more kind of friendly to lifestyles. It takes less time to charge your car. And I think that's something we should look at. EVs, of course, are driving investment in a lot of other technologies. So battery technology funding for general companies, this is not just venture capital, went up quite a bit in 2021. But the important thing is that in these enabling technologies, you are seeing active roles for startup companies too. The top investors in electric vehicle technology and in the world, GGV Capital and IDG Capital are both China focused. Hyundai is investing a lot in China now, Sequoia Capital China, and also Matrix Partners China. So you see that the investments are really running ahead. We should move on faster in the US. The bottom right-hand quadrant of that chart that I showed had to do with rebuilding supply chains. This is important because on average, in a big company, 11.4 times as much emissions is generated from their supply chain partners than come from their own operations. So one good point of where we are right now is that 38% of the Fortune 500 companies worldwide have delivered a significant climate milestone, or they're publicly committed to do so by 2030. This is up 8% over 2020, so 8% in 1 year. Interesting examples. PepsiCo is helping supply chain partners measure and improve their footprint. Thanks to that, bottlers in Latin America achieved a 50% decline in emissions. They're also focusing, PepsiCo is focusing on upstream agriculture products to include renewable energy sourcing for the sources of what they put into their drinks. Microsoft has revised its supplier code of conduct to require disclosure of, quote, complete, consistent, and accurate greenhouse gas emissions data, not only from the company's own operations, but from the company's supply chain, the Scope 3 emissions. Apple has a similar program. And the list of companies like this goes on. I haven't yet seen how far we are on the way to achieving, better supply chains in this regard, though. Major technologies are being developed, such as I mentioned, hydrogen-powered turbines to replace gas-powered turbines. Also, renewable energy is definitely on the way up. McKinsey, just at the end of last year, predicted that by 2026, only 3 years from now, global renewable energy capacity would rise more than 80% from 2020 levels. And this is hard. I would like to relate that to the charts that Dr. Zhou and Dr. Lechert showed. I don't know whether that's sufficient or not. On transmission, AI-enabled smart grid management will be a big thing, and it is certainly something that the large grid management companies are engaged in, the electric power companies. With regard to distribution of electricity, this is where the smart buildings comes in. And I noticed that that played a prominent role in Dr. Lechert's presentation. While individual components are often developed by startups, it's really the big players who can deal with these entire system-wide efforts, change on a big scale all at once. But we still need disruptive change. And I noticed that Dr. Zhou mentioned that not only accelerating the use of existing technologies, but behavior change and innovative technologies would be necessary. So this is where the startup companies come in. We are seeing an incredible jump in the amount of venture capital that's being invested in what most of the investors hope will be disruptive innovations, because they hope for that kind of growth. Europe leads the way. America is a close second. And unfortunately, Asia, including China, is far behind. So we need to do better on a global scale. If you look at the regional share of venture capital and climate tech, I think that China did account for about 33% of climate tech specifically, and Asia, except for China, accounted for a little over 3%. If you look at the top 10 places where climate tech venture capital is being done, you see the United States, San Francisco Bay Area being the first, then Shanghai, Beijing, Los Angeles, Boston, Guangzhou, Nanjing, Hangzhou. Finally, you get to Berlin, and then you get to Bengaluru. So I do think that China is leading the way in regard to private sector interest in developing this kind of new approach that may be disruptive. But note that almost all of the investments in China were in the mobility and transport sector. In the US and Canada, you get a more kind of balanced view where you're getting investments in a number of different areas, as well as mobility. Part of this is supporting the EV industry growth in China. That industry has moved out ahead. it's going mainstream. So it's rapidly leaving the startup company world and going into the big company world. One of the things that is ramping up in China is fuel cell buses. This is interesting because it's a great example of international cooperation. Ballard Systems, which is a Canada-based company, has been providing fuel cell hybrid buses to cities in China, and this is growing. And the different cities in China are really growing out this kind of area. So in Japan and Korea, you also see a push for fuel cell hybrids. There are 3 fuel cell hybrid cars that run on hydrogen available in the United States. Basically, sales is still next to nothing, partly because there are very few hydrogen charging stations. Note that China has already announced government raising awareness, setting goals, and kind of leading public opinion that they're going to have 1 million fuel cell electric vehicles on the road by 2030. Sure enough, Hyundai is planning to build a fuel cell factory in Guangzhou, and we'll start making 6,500 units the first year, but they're planning to make 730,000 fuel cells by a year when the factory gets to its full production. Hyundai has also started its first production models of a large fuel cell powered truck. So you're seeing this kind of thing, but then we get to another area where, frankly, the big players are kind of not there yet. Most hydrogen production in China is gray. That means that the energy source for the hydrogen is probably natural gas, fossil fuels of some sort. And the process of making the hydrogen is reforming or gasification. So moving from that to truly green hydrogen, which does not create CO2 in the process of producing the hydrogen, is important. You are seeing governments state that they want to move in this direction. You're seeing governments investing money in this direction. You're seeing big companies invest in this direction. But this is one example of an area where I look at the startup companies and I see very exciting things. So I did a quick search yesterday, frankly, and found 34 startup companies that are either built around the production of green hydrogen or doing some sort of enabling electrolysis technology for green hydrogen production. Most of these are in Europe. There are a few in North America, but I also found some in Brazil and Southeast Asia. I did not find any in Japan, Korea, or China. I think I would have found some in China if I had been searching in the Chinese language. Just one of these to feature is this company called Electric Hydrogen, which is not only a startup company founded in 2021, they have already raised $222 million. So they're now officially a unicorn where the valuation of the company is worth more than $1 billion. They have new electrolysis technologies for industrial production of hydrogen for use in industrial plants, not really electric power generation for the power company, but for use in steel plants or plants that are making ammonia, freight transport industries. So among the backers of this are some major VCs, especially energy-related VCs like Breakthrough Energy Ventures, loans from the Silicon Valley Bank, although this is a Massachusetts company, and strategic investors that include some possible users of what they have. Rio Tinto, the mining company, Mitsubishi Heavy in Japan, Honeywell, Kosan, and also Amazon. So this is the kind of thing that we're seeing going on. The most important role of the private sector industry is to deliver new things that people want. Society needs both big new systems and disruptive new ideas in order to achieve these very challenging ratios of carbon reduction. The big companies are addressing near-term market opportunities at large scale. They are conducting advanced research too. Some of their research will eventually go straight on into their new market development, but they tend to be biased and follow areas where the company is already strong. It's really the external startup companies where you can look for disruptive innovations that will really incentivize people to change their lifestyles. Disruptive innovation typically starts with a new market using a new technology because that's the high risk. Then as that technology becomes more established, either the big companies see that this is working and they buy the whole company, or people basically start to replace their existing way of doing things with the new technology in other areas too. The market spreads and takes over the mainline markets. So big companies are finding ways to partner with startups in order not to be disrupted along with these changes in market behavior. They're buying from startups that are selling to business. And there's also a lot of open innovation relationships between big companies and startups, joint development projects, proof of concept demonstrations, corporate venture capital investing. The range of things continues. So it's an exciting time. We should all feel incredibly challenged. We should all feel that none of this is guaranteed. But I think that with the combination of awareness of the things that have to change and people who turn that awareness into business opportunities, we can do this. Thank you very much.
Yeah, thank you very much, Professor Richard Dasher. So this was excellent talk regarding private sector for the decarbonization. So they did, significant contributions and venture capitals and so on. This real world will move the government and other things really be the real world. Okay, so for our Q&A sector, so we will welcome, Dr. Apple Zheng. She will be the moderator. For the time, we will increase the 10 minutes, so we'll keep the 40 minutes quality time for Q&A. So welcome, Dr. Zheng.
Thank you for introduction. Yeah. So when educational webinar with Dr. Zhou, Virginie, and Dr. Dasher in-house to discuss the decarbonization pathway. So by diving into gaps and roadmaps in different sectors, discussing the challenges in implementation, comparing the energy outlook and solutions for different countries, we learn how to play a role in creating a more sustainable future for ourselves and for the future generations. So here comes the exciting Q&A section. We collected some of the questions for the speakers. The first question is, what is it like working with a global team to produce an IPCC report? Do you see the possible adaptation required to achieve the low global warming level varies for different countries?
Okay, yeah, so I can take on this question. So actually, this was my first time and to be a IPCC lead author. So it was more like a freshman or freshwoman, and for this really noble and research. And it also was interesting time because the whole time we were writing, actually majority of the time we were writing the report, it was during the pandemic. And so it was delayed by close to a year. But also made us to try different working models, like remote kind of a meeting, because in the past, all the IPCC report authors and they got together and 3-4 times a year, really in person, and spend the whole week working together and writing different chapters, outline, and also there's cross sector and the linkages. And so I think this experience is fascinating. In the beginning, we did meet in person about a year, and working with a very diverse and educational background, researchers, scientists, peers. And they could range from social scientists and financial people from financial institutions, private sector, but also academia, and some are like a policy and kind of making government think tanks. And so people come from different backgrounds. And also because it's quite an interdisciplinary and the research, and so it's a very fascinating learning as well, and to see the different perspective. For example, the chapter and I was involved in, it's about the near and midterm and pathways for future. So I'm from the Lawrence Berkeley National Lab Energy Technologies area. We've done so much work on technology. But on the chapter, we do have a really social scientist and who talked a lot about behavior, but also the human aspect of the transition. For example, equitable transition and energy justice and the well-being, not just about mitigating technologies, but also how we can really improve the well-being of human, particularly in those developing countries. For example, we can't ask them to leap forward to electric cars or fancy and equipment when they are still, for example, living without electricity or riding donkeys and horses. So yeah, this writing this report really and made us to realize there's really different objectives and development agenda we should consider at the same time when promoting technologies. And also when we started working virtually, it was very challenging because from the West Coast, and it was always 4 or 5 a.m. in the morning because to accommodate authors from 100 countries or in our chapter maybe from 14 countries, it was hard to find a common time. So it was a very challenging, tough for us, and in particular for those with young children, they have to care for, and they were all staying home. And so everybody made a significant sacrifice and effort working together. And also I want to mention this is really team science, right? Sometimes it's even hard for a small group of us, 4 people writing one paper, right, or chapter. And when we have different opinions, different views, so it's even hard when we have how many people for our working group. We had 150 or 200 scientists around the world working together. And so overall, I think it's a fascinating experience. In terms of the different countries, what we found, at least in this chapter, is for developed countries and the path forward is more straight, and some of the countries already embarking on the net zero pathways, and some has set very ambitious target achieving that even before 2050. But we found a significant challenge and still reside with the developing countries. Very little publications even we can find, for example, in Southeast Asia or Africa. And then also the future pathway, and it's even more challenging because of people there still need to develop. and they still want to live an urban life, a modern lifestyle, and one needs to have electricity access. They need to have a basic shelter, and they need to be cooled during the heat waves, right? So and so all these introduce more challenge and for us, and to come up with strategies that can meet multiple objectives. And then I think you also quickly mentioned about adaptation. This is actually there's a focus in the working group too on that. And as we are falling behind meeting our climate trajectory, we are already facing consequences, right? More heat waves and more extreme weathers we already experience even in California Bay Area, right? We now need to install air conditioners in East Bay. We never had it. And also we have more storms, rainstorm, windstorms, and our power line and it was interrupted because of a tree falling down or wind or all of those. So we need to adapt to these new situations, and whether it's energy systems and power grid, but also for our homes, and what are the things we need to do and to cope with more drought, more flood, and more power outages, and all of those. So yeah, so that's a very quick response.
Thanks, Dr. Zhou, for sharing the fascinating experience and all the challenges encountered as the scientist for IPCC report. Next question we have, I think this question is for Dr. Desher. For the private sector, what are the keys to achieve the low global warming levels?
Well, I think that, first of all, they are going to be operating in an environment where demand from their customers as well as pressure from government regulators will be important. So, you know, Dr. Zhou, you mentioned that people are very aware of the difficult weather patterns that we're having now with wildfires and so forth. So I think that one of the things that encourages me is I just saw some statistics yesterday that people are actually considering the ESG ratings of companies or the reputations that the companies have in what products they're selecting. So I think that, you know, every sector has its own responsibilities. Energy really needs to be very aggressive. All industry probably needs to be more aggressive than it is, but it's really going to be the pressure from people as well as from the governments that move the companies to develop the new solutions. Thank you.
Yeah. How can long-term electricity forecast used in infrastructure planning and policy modeling account for the impacts of electrification and demand flexibility on load shades?
Thanks, April. I'll take that question. Well, I think, so in my presentation, I did up showing the infrastructure analysis we did for Indonesia. I think it's a very good example of, you know, how the load shape and how the way we use our appliances and equipment is going to impact the demand. I think the key in this type of modeling that we are doing is really this bottom-up modeling, this accounting, very tedious, but it allows us to have some foot in the reality. Like we are able to take into account saturation effect, for example, that people will have, you know, not more than one refrigerator per person, for example, given number of light bulbs, you know, in the industry, you know, how much cement is needed or forecasted to be produced. So all of our drivers we're trying to do physical drivers in order to capture better those forecasts and the future impact on the infrastructure. Thank you.
Thank you. That's good. Yeah. Next question we have is, what do recent declines in wind, solar, and battery storage costs imply for the optimal pace and scale of the development of these resources over the next 15 years in China?
So I think that's a question for me. And so the wind solar price or costs have declined so much, largely and attributed to actually China's development of various policy, incentivize manufacturing of those, and the ability to scale up. And then China's has already become the biggest installer of solar and wind, and the leading on battery technology development. And I think China is doing already as much as they can in terms of renewable energy development and decarbonization of power sector. And going forward, it's not really only about the cost economics of renewable. There are barriers, other barriers, institutional barriers, regulatory barrier, and that could be because of the dispatch order currently China is using. It could be because of interconnection issue. It could be because of a tariff for different industrial residential customers. And so going forward, and we need to work with China to really overcome these barriers through new policies or analysis. And many of those, like our scientists in California or in US, have already done or tried, and loading order and environmental dispatch, decoupling of electricity sales and from production, all of those, and we have tried. And in these developed countries, could provide and really insight and suggestions for China. And so at the same time, I also want to point out the scale that we need to achieve to fully decarbonize the power sector. So right now we are seeing in our scenario by 2045, China can achieve carbon and fossil free for the power sector. But that's because we set the target for that. When we did a economic optimization scenario, we still have coal. Coal is still in the system, and by 2050. And so it shows that beside these economic kind of and aspect of renewable, we really need to think more also about and the feasible policy levers and the business models, and Professor Dasher also introduced and innovations to really help scale up the renewables. That's not a purely economic problem.
Yeah, thank you for sharing other perspective, such as looking at barriers and all the different collaborative fields to look into this question. The fifth question we have. What are 1 to 2 of the most important actions we can take to reduce the greenhouse gas emissions and adapt to the climate impact?
I guess if that's to me, that's a market question, right?
Yes.
Because I think that a couple of things that are really important that we should do is focus more on the circular economy. I think that we haven't talked much today about plastics and so forth, but single-use plastics we should all just get rid of as much as possible. And I think that also adopting to the extent that we can, right, in our economic conditions now, adopt solutions that are good, electric vehicles, or, you know, and they're still quite expensive in the United States. Or in some places, you can tell the power company which power you want to receive in your home. So there are a number of things that we can do. I think that the most important thing, like Dr. Joe said, there's no one silver bullet. You really have to try everything to be more conscious of what kind of impact you have on the planet.
Thank you. I actually didn't know we can choose the power company for our home separately.
I think you can in Palo Alto.
Oh, wow.
I think that
That's
you
very
can
advanced.
specifically say, you know, I want to have all renewables as in my power sources.
Nice. Yeah, Palo Alto
You
is a
might pay more.
Yeah, okay. Makes sense. Yeah. The sixth question we have is, how can uncertainty in electricity demand be best captured in demand planning, land use, and policy studies? I think Virginie can help us with this.
Yeah, so the key is really to understand what are the drivers of this electricity demand, and then to understand the variation on these drivers, and that gives you kind of the lower number, or the band that the policy should, you know, be able to accommodate for. They should be ready for this variation. So yeah, we do sensitivity analysis, for example, to deal with the uncertainties. You know, we look at population, what is the low growth population versus the high growth, economic growth, of course. Yeah, what is the rate of energy efficiency improvement, the price forecast, so that can vary widely. But yeah, I mean, uncertainty is part of the of putting together a forecast. So you, yeah, the policy planning has to accommodate for that.
Excellent, thank you. The next question we have is, what mix of policies and markets can help to rapidly increase the scale of electricity storage? How can we accelerate the development of emerging technologies, research, and design?
So I'll take this one a little bit. This is one where you have to look at who funds research and development. For the really basic kind of research and development or basic research that doesn't really have obvious application yet, some of the really emerging technologies have to go back to scientific problems. The source of funding is almost always the government, no matter where you are, no matter what country. And interestingly enough, you have government labs, but you also have universities getting a lot of government money for basic research. That's where most of the basic research at universities is funded. Then there has to be some sort of a transition to industry, because late stage product development, no matter what field, is almost always done by industry. So I think that what we need to have is a good kind of mechanism for knowledge exchange as well as technology transfer, because a lot of the new technologies require more than just a patent or a license that you could buy. I think that supporting these is something that the government national budget is a major factor. I think that as people see things you can do with it, the venture capitalists are typically looking at possibilities 3 to 8 years in the future outside medical fields. And so they have to look even further in the future in medicine. But once you start to see that this could be used to create value in a market, then it naturally shifts over into the private sector of business. Thanks.
Thank you, Dr.
Can I add a little bit on
Yes,
that?
please.
Expand? Yeah, so I totally agree with Professor Dasher. And first of all, we need to have the, whether it is a market mechanism or government investment, and really accelerate this tech to market, which happens and between the early stage developing the national labs, university, and do, and also what the industry will do really is late stage. And there's that gap and the value of death, right? And that's where we need a lot of investment in these days. And so a lot of what our national lab colleagues does early stage, we develop it and we put on the shelf, and then we start working on the next, right? And then so 10 years later, still not commercialized, right? But so it's the industry, sometimes they are struggling, they're facing challenges, but we really need this and somewhere in between, somebody can help bridge the gap to look into these early stage and research, and to see how some of these could be used. We need additional research there, right? Need a new innovation, so that could be used by companies, industries to address certain problem. And so that's where we need a significant investment, both from government and from other, I think, venture capitalists. And these days, they probably also and try to invest in that space. That is a little bit risky, more risky, and so it's harder for them. But that's where also government can come in. I think the U.S. started and started doing, CEC started doing that program EPIC, right? And the DOE also started looking into that. But in China, I think that's also where it's really needed. And to help really bridge the gap.
Thank you very much for adding that. I agree with you 100%. Not only to carry the people with the early stage technologies to the point that they can be commercial. You're right about EPIC. Also, I was thinking of the Small Business Innovation Research Grants, which are grants, right? They're not investments. Those have been very important in the US. At the same time, to accelerate the growth of the market, subsidies and tax breaks and so forth from the government to people who, for instance, buy electric cars. That's really important too. Thank you.
Thank you. Yeah, so I think the efforts towards the decarbonization really requires collective from individuals, business, and the government support. So the next question we have is, what are the efforts towards the behavior changes to address the challenges introduced to the power system?
Should I take that?
Yes, please.
I think that, if you look at kind of things people are influenced by, they are influenced by incentives. They're also influenced by laws and regulations. And I think that when you really need to have a behavior change, on a case-by-case basis, you have your choice between laws and regulations, incentives, kind of positive things on the other side, and also this thing in the middle called standards, where you announce goals and you announce kind of ways, and what are the ways to measure what you're doing. Unless people can measure what their kind of carbon is involved in their own daily activities, it may be very difficult for them to change their behavior. That's one we haven't gotten yet. We haven't gotten to the carbon credit market yet because we don't really have a standard for how to measure it. There are several competing standards, but it's going to be a combination of laws and regulations, some sort of a standard that you either have to adhere to because of a law or you want to adhere to because it helps the value of your company or because it makes you look good in the neighborhood, and then the positive incentives.
Yes, always, and Professor Dasher inspire me to have more thoughts. So there are a range of things we can do to help change behavior, but which is, I think, one of the hardest to change, right? We always tend to go to technology. You know, we can buy an electric car, we can get and fancy, you know, like equipment, heat pumps, all of those. But if you want us to change our behavior, it's very difficult. So if I would, it's a personal opinion, just name one or two really, in my view, important policy or lever. One is the standards, and Professor Dasher is talking about. If it's mandatory, right? Without us thinking how we're going to change, it's already changed for us, and so the companies already and have to develop more efficient appliance. They have to use a cleaner fuel. And there's a demand response help us reduce the peak load and some of those. So I think the standard definitely is one of the key policy that we need. The second part still is not rely on us, and because we as a human, we're vulnerable in many sense and to changes, but also we're lazy. And right, and so how many times I forgot to turn off my lights or heater when I'm out, or in the standby power, right? Just pull the plugs, and that it's just too much hassle trying to, you know, and how many devices we have in the house. So I think that's where AI or smart control and this could really help us, right? If we have these a control algorithm, it's a program. I don't have to do anything, and I just need to press a button and say, can you help me reduce 10% peak load or energy consumption? You can optimize for me, then that will get done. And if we rely on us, people, I think it will be very challenging.
Yeah, this is a very inspiring discussion. I hope we get to the carbon credit soon and have regulations and standards in place soon. Yeah, I think that's all the questions we have today.
Yeah, thank you very much, Dr. Apple Zheng. You know, excellent Q&A session, and also appreciate all our speakers. You know, give the good answer for all the questions. So due to the time, you know, limitation, so our webinar continued for almost 2 hours. However, in the end, I would introduce the 3 professors from the Chongqing University. So they participate today's webinar. So I would give each one opportunity to say the few words, you know, regarding today's webinar and discuss. So who will be the first one? So either I just call the name. So the first is Professor Fang Shidun, Chongqing University. So could you say a few words? No?
Yeah, Professor Fong is in meeting. I will talk on behalf of him.
Okay.
Yeah, so everyone, this is Qiu Shi from Chongqing University. And yeah, I would like to thank everyone for this talk, and this is very, very inspiring. And I was discussing with Shanghai Electric Power Company a few days ago on a offshore wind turbine on a offshore wind farm project. In that discussion, it reminded me some policy and market-driven change that we would like to, we would hope it to happen. There is a question on, when integrating some offshore wind farms, right? There are some problems for different manufacturers. There are different type of wind turbines, and they don't have very good parameters of those wind turbines, because each private company or manufacturer, they might hide some key secret, right? Some key parameters for their products. That made some problem when we are integrating those different types of wind turbines into the electricity grid, right? So without that, when integrating those renewable energies, there are some frequency oscillation issues, right? That make the engineers in this field very difficult to do such engineering work. Therefore, I hope, right, the policy should, right, the manufacturers should be open and not short-sighted. If they would like to share some product data and we integrate those data into our simulation, we can make the integration of renewable energy easier. And at the end, in the long term, it's good for those manufacturers, I think, right? So their products will be promoted and simulated and operated by all the researchers and the engineering project. So therefore, I hope the policy and some manufacturers, they can see longer, right? They can look in the long term, and we hope more renewable energy will be integrated and we can achieve the carbon neutrality faster. Yeah, so that's some 2 cents, and yeah, thank you. Director John, you're muted. Yeah.
Yeah, thank you very much, Professor Cui from Chongqing University, to participate in our webinar today. So yeah, so we have a lot to say and a lot have to discuss and a lot of expectation, because really, excellent work from the Dr. Zhou's team and also from Professor Dasher. So however, the time constraint, we will end of our webinar today. So I would appreciate everyone if you can turn on your video. We can take the group screenshot. April Zhen. Yeah. So yeah, if everyone is ready to take the April, can you do it? Yeah. So we just try, take the video. So we expect we'll have other webinars or conference. Maybe in the future we meet offline. So we'll be physically in the conference room. I believe pandemic will be over. So last question, for the Dr. Zhou and Professor Dasher. So your PPT, can we share with our participant? Okay.
Certainly. I'll send you my slide deck again, because there was a couple of mistakes in the first one.
Same here. I noticed some typo too. We'll fix that and send to you. Yeah.
Yeah. So we just wait your new PPT and share to our participants. I believe all the participants in the US or in China will be really appreciate because the webinar is very concentrated to discuss. However, in writing will be more help for them. Okay, thank you very much. So we will have a good weekend. Okay, bye-bye.
Thank you. Bye.
Bye.